So my name is Jeremy Foran with BAI Communications. I've worked in the transit industry for about 10 years, primarily with connected trains. And I've been with BAI for roughly 5 years now, and I lead the data analytics team here in Toronto. So I'm going to walk you through who we are, what we do, how we were introduced to Influx, and then the problem we set out to solve. So, BAI Communications is a global company. As a leading communications infrastructure provider, we deliver neutral host solutions that enrich the lives by connecting communities and advancing economies. To achieve this, we focus on 3 key verticals: broadcast, neutral host and 5G, and transit and safety. Today, I'm going to be sharing with you some of the work we do in the transit space. So in Toronto, BAI owns and operates the infrastructure that provides public-facing Wi-Fi and carrier-agnostic DAS systems. The idea here is that once you have built infrastructure to provide wireless connectivity in the subway, adding additional complementary services becomes very cost-effective, which is what you see in this diagram. So you can see there's a lot of revenue opportunities and applications to utilizing that backbone fiber infrastructure. So here in Toronto, we started with wireless connectivity in 2015. And then over the past 5 years, we've expanded to some of these various other services. So for example, providing connectivity to all of the digital signage at platform level. This is the next train, arrival systems. We provide dark and dim fiber connectivity for the fare card payment system. And currently we have a lot of POCs that are ongoing that cover some of the applications you see here. So that is BAI. In terms of focusing on the transit, some of the challenges are cities are becoming denser, more people are commuting daily, and the rail operators have to meet these concerns with limited budget and aging equipment. As a result, they're turning to technology to address these growing demands. In 2016, Trains for London published a white paper outlining potential solutions in the underground, and they were all based off Wi-Fi analytics. In 2018, the TTC published their 5-year corporate plan, and in that we saw roughly the same applications of Wi-Fi analytics to solve a lot of the same problems. It really boiled down to just 4 business objectives that they're trying to solve. So number 1, they're trying to nudge riders. In cities like New York, there may be a couple of dozen different routes to travel from Midtown to Soho. Operators may be able to relieve congestion on specific lines by nudging riders to take one route over another. This can have cascading benefits across the entire travel time of the train network. Number 2, investments. Where are they going to get the most bang for their buck or the most juice for their squeeze? If rail operators are armed with good origin destination studies, then they can pinpoint the stations or tracks where investments will have the greatest return on rider satisfaction. Resource planning. So the operations departments want to design schedules which effectively move the most people to their destination in the shortest amount of time. And finally, rider safety. Safety in the rail industry is the paramount concern. And one aspect of that safety is platform overcrowding. And so this is the solution I want to share with you today. So platform overcrowding. If you've regularly used the subway system in any major city, you are probably familiar with what platform overcrowding looks like. It's inconvenient, there is little to no space to move, and it becomes different to board or disembark the train. In terms of safety, once a platform is overcrowded, it becomes difficult to evacuate the station in the case of an emergency. Basically, the entrance and exits become bottlenecks. And also the risk of somebody falling off of a platform goes up as more people push into an overcrowded station. Typically, safety staff have to monitor thousands of camera feeds, trying to identify places where overcrowding may be occurring. In an environment where people are constantly moving in crowds, you can start to imagine how hard that would be to flag emerging issues. So before I get into our solution and how we address this, I just wanted to share how we came familiar with InfluxDB. So in the Toronto subway system, BAI provides T-Connect, the public-facing Wi-Fi service that I mentioned earlier. It's pretty popular. We see roughly 100,000 unique devices join our network each weekday. To support that many daily users, we have almost 1,000 access points deployed, 3 data centers spread across the city, and hundreds of servers, networking appliance, and virtual machines, all playing a role in delivering Wi-Fi to that router. Simply put, there is a lot of moving parts. In Toronto, the dwell time for riders during rush hour is roughly a minute. So we really need to optimize and reduce the time it takes to get connected to the Wi-Fi service. We have the typical network monitoring solutions in place, the NMSs, but it can still be difficult to get a sense of what the user's actual experience is. So one place you may turn to is social media to get feedback on, what the user's experience is. And if you've ever offered any service to the public, even if it's a free service, you may come across tweets like this. So T-Connect Wi-Fi sucks. I don't care how unbelievably attractive the engineers are. So this isn't a real tweet, but this is the kind of feedback we see from time to time. And while it's descriptive, and while the description of the network engineers is very accurate, there isn't a lot of technical information to aid us in an investigation. So, did you experience a DNS issue? Was your DHCP acknowledgement taking too long? Do you not like the color of the terms and conditions page? And so we were looking for a solution to try and really get a sense of what the user experience was. At the time, there were a lot of companies selling software that tests the bandwidth or the quality of the Wi-Fi signal, but not the onboard process and what the user experience was. So we decided internally that we would build a small box that would emulate the entire process, from the initial scanning of the SSID right to the full access and connection to the internet. So enter Project Touchstone. So what we took was a Raspberry Pi. We wrote a little Python script that captured and timed every single element of that onboarding process or connecting to the network. And we needed to store the resulting metrics. This was 2016, so NoSQL databases were just starting to get traction as an alternative to relational databases. And there was a handful of options at the time, but the web interface of InfluxDB really sold us. Being able to see the graphs as soon as we're committing information to the database without having to build, visualizations or endpoints, was really powerful, and we really liked it. It was a really great feature at the time. Since then, we've really used Influx as our go-to time series database because of that flexibility and ease of integration. All right, so getting back to the platform safety and detecting overcrowding. What we first needed to do was establish that the Wi-Fi associations served as a good proxy to the amount of riders in a given station. And so we conducted a study of the Wi-Fi data and concluded that the correlation was 0.9. So that's a correlation between the Wi-Fi usage and the ridership in the subway. This isn't really a surprise. You might expect that the more people in the station, the more people using the Wi-Fi. And with that strong of a correlation, we knew that we could build an effective analytics based off of the Wi-Fi data. So what does that look like? This is the associations over a single day for an entire station. And there are some things that are quite clear. So the start of the service, the morning rush, the evening rush, and finally when at the end of the day, when the service is no longer running. You might notice that this is fairly spiky. So if we zoom in and see what these spikes look like, the pattern you're seeing here is due to phones actively trying to join the network as the trains pull into the station. So, there's a couple hundred people on the train, they each have a device, and as the Wi-Fi becomes available, or the train is pulling into the Wi-Fi footprint, their phone is actively trying to join that network, even if the device is sort of tucked away and put in their pocket. So this means that this problem wasn't as simple as detecting when a threshold is breached. What you're really trying to do is determine when there is a change to this peak and valley type pattern. So let me share with you a sample of when overcrowding occurred, and you can see if you can try and tease out when there was, when overcrowding started to occur. Okay, so of course, I think it's easy to detect that change in that pattern because it's so pronounced when you look at the data. And here you can see just how disruptive this was. You can see how the disruption to the service had affected the overcrowding at the station. And it also informs us how long this disruption lasts. Now, if we zoom out and look at multiple stations, you can see how this interruption rippled through the entire train network and caused delays across multiple lines. So now we know what the signal we're trying to tease out. So we want to build out the solution, and this is what we built. The gray area represents the existing Wi-Fi equipment. So from left to right, we built a little VM with a Python script that basically screen scraped the associations from the wireless controllers. The script would add a bunch of metadata or tags so that we can, oh, I went ahead, sorry. So we added a bunch of tags so that we could group the APs in different logical groupings. An example would be, everything at platform, or if there were a few access points that are located in a walkway between, two platforms or two close stations, we might want to include those or separate those out when we introduce the business logic. So we would then use chronograph to get a sense of the unique patterns of each station. As there are 75 stations in Toronto, each one is a little unique in the traffic profiles, the square footage, RF performance, etc. And because of that diversity, we define parameters for each station that get pulled into the business logic. These parameters function as dials and knobs that allow us to tweak the business logic on a station-to-station basis. It also allows us to have multiple different configurations for different consumers of that business logic. An example of different consumers would be, there are different departments inside the TTC, and they might want to subscribe to notifications, but based on different severities. So then we publish an API through API Gateway that controls the access to the Influx database and business logic. But what this really does is abstracts away the complexities so that we're producing third parties just the insights they need. For example, an operator only needs to know that maybe Christie Station is in a good state. They don't necessarily need to be burdened with, all the different queries that need to be run or all of the data that may be returned by the query. They just need to know, is this station in a good state or not? Then finally, we implement various security best practices to keep this whole solution secure. And what do we finally present to the various consumers, the rail operators? Here's an example of a dashboard we built. It's very simple, sitting on top of that API. It's just a simple React dashboard that updates every couple of seconds, constantly recalculating the condition or state of the platforms based on those Wi-Fi associations. So looking at this, you can imagine how this might aid safety staff who are trying to keep tabs on thousands of camera feeds. I mean, now they can be notified or their focus directed to stations where they might want to hone in or do an investigation to see what the current status is. So this was some simple code to collect the metrics, a handful of cloud services, and Influx as the cornerstone to this solution. And Influx really allowed us to do things like introduce tags and aliases, like internal station IDs, while in production with zero downtime. So we would update the script to append new tags, publish a new API along with the existing versions, and then return those tags to the consumer without having to take the database down or redesign tables or associations or anything like that. So this means the entire solution, took us hours to publish new versions or make amendments to the information that was included in the data logic, hours instead of days. And that's really the kind of agility that Influx provided us. So to bring it all together in summary, rail operators need real-time information on platform overcrowding in order to address safety concerns. Existing wireless infrastructure can be leveraged to deliver this value add, and InfluxDB enabled us to quickly and effectively develop this platform overcrowding solution. So that is my presentation. I feel like I did it in under the 30 minutes allotted. So more time for questions. Happy to dive into any sort of technical depth and field any questions you might have.
So, so you've been using InfluxDB for a while. So if you were to give advice to yourself from, when you first started, what would you do a little bit differently? Or what were some of the things that you felt like, oh man, I wish someone told me?
Well, first off, probably invest more in Bitcoin. If I would have done that in 2016, my life would be very different now. But I think what I would do is, that's a great question, probably leverage more of the SaaS model as it became available. So the cloud offering that Influx has. I'm not exactly sure when that became available, but when we went to build this solution, we really relied on it, and that's the direction our team is starting to take, leveraging more SaaS so that the solutions scale as the requirements need to, right? And where previously we were running everything in-house on VMs, so that's probably, I would have used Influx more sooner and in the cloud model. And Bitcoins.
And Bitcoins. Okay, so we do have some questions. So let's see. Monty asks, very nice presentation, by the way. He says, how do you stream data from multiple sources at high rates? And are you using multiple telegraph connectors?
Oh, that's a great question. So with this one, for this particular solution, all of the information from the access points, so the thousands of access points, are actually coordinated through the wireless controller. So we're actually just talking to a single, web interface. We do some screen scraping where we pull all of that information from one point. So in this case, we have a single script or service running to pull that information. In terms of pulling stuff from multiple places, multiple endpoints, we've used Influx for SNMP collection, and I've never, I think it works so well, we've never really had to do an investigation on, optimizing that. I think it's more or less worked for us right out of the box.
Um, so
Nice
what are
try,
you,
Monty, trying to give me a tough one there.
so what are your plans for the future? Are you going to be, are there more like other data sources that you want to collect to try to do some forecasting or?
Yeah, we're really excited at using Influx 2.0 more. So we're starting to kick the tires on that a little bit. As you saw, we have some of the business logic is actually run outside of Influx. So we're just using the database, but we'd really like to look at some of the internal analysis and forecasting and how it might apply to solutions like this. So, in Influx, there's the halt winters function. And when we looked at that, it didn't quite line up with this use case, but I believe some of the anomaly detection, might be a very elegant solution to detecting those changes in patterns, which you saw in, some of the previous slides. So I think that's really what our roadmap is understanding the features that Influx is developing and seeing how we can incorporate them to simplify the overall solution.
Solomon asked a great question, and I actually have a follow-up to it. What is the data collection rate? What's the infrastructure to support it? And I guess I'd like to understand, how many different series, how many different data points, what are all the different things that you're collecting, from a volume perspective?
All right. So a few parts to that question. The first one being how we're collecting this, the infrastructure to collect this. It's a VM. We have a virtual machine which pulls that information every 5 seconds. So the trains run every 2 minutes. The trains run every 2 minutes. We really want to understand the overcrowding. So we're trying to balance the most granularity or the highest rate of collecting that data versus taxing the wireless controllers, right? So it's all about that balance. In an ideal world, we'd be doing it, in sub-seconds. But the trade-off there is that, increases the usage of the CPU of the wireless controllers. So it's about finding that balance. We looked at 5 seconds, polling every 5 seconds, and that gave us some really good graphs, and we're able to detect those changes in the patterns, pretty easily with that level of granularity.
And so the Wi-Fi is in the stations, or is it also on the trains?
Today, it's in the stations. We are always looking to connect trains and provide public-facing Wi-Fi on board. That's, as I mentioned, I've been in the industry of internet on trains for the past 10 years. So that's a big part of some of the projects we work on is developing systems to, connect trains. That also goes back to leveraging the existing infrastructure. So the fact that, we have already built fiber to each station and have, all of the required equipment, it becomes that much easier to do, to shoot ship-to-shore radio connectivity to the trains, either down the tunnel with directional antennas or leaky coax.
And how far away are the stations from each other? I asked that because I was just thinking about what does that handoff look like, right? So, how long do, passengers hold on to that Wi-Fi connection, and then, when does it let go, and then when does it try to connect to the next?
Yeah, so that's a great question. And it's a fairly complex answer. So much so that you could Google the term sticky Wi-Fi clients, and you'll find a bunch of white papers published by the major Wi-Fi appliance or Wi-Fi equipment manufacturers like Cisco that provide tactics to deal with that idea of sticky clients. So an example would be that as somebody enters a station, they enter, they walk down the stairs to the platform level, they're walking past multiple access points. And the phone gets to decide, what its behavior is or how long it holds on. And sometimes they're not making the best decisions, one, because they might be trying to aggressively hold on to modulation rates and not aware that there's going to be another access point for them to join, right? Or it could be things based on the battery levels of the device. So there are about 100 variables that are made up in the operating system that are calculated and aid in that decision of when to jump from one access point to another. So it's fairly complex, probably a little bit too much to answer this question directly, but there's a ton of material on the internet about sticky clients, right?
Okay. So I sorry, that was a little bit of a digression, but Siam asked, so what are the average number of series that you're sending to InfluxDB?
Yeah, so there's 1,000 access points. So every 5 seconds, we're collecting the amount of devices connected, and then some RF properties like signal to noise ratios, interference, and those sort of things, so that they may aid in creating a more complete perspective on what that environment looks like at the station level. So let me just back up a little bit. It's not just the associated access or the clients associating to the access points, which may indicate how many people are there. So if, let's just say we had 100 devices at the station level and not a single one of them was connected to our Wi-Fi infrastructure, they're still actively, scanning for Wi-Fi networks and things like that. So we may be able to tease out information simply by the RF interference and not necessarily just the amount of connected devices. So we have the Wi-Fi associations of each access point, of which there are thousands, and we have a bunch of the RF properties. And then from there, we add a lot of tags like where it's located in the station. Is it platform? Is it entrance? Those sort of things. And a few other properties that allow us to group those APs when we apply the business logic.
So Siam asked a follow-up to that basically. So how are you managing the cardinality? It sounds like you're using a lot of tags. Or have you guys figured out a way to limit the number of tags?
I wouldn't say a lot of tags. I think, 6 or 7 different categories, and each of those only has a handful. I mean, the stations has 75 different stations. The AP is going to be tagged with one of those 75, right? So it hasn't really been an issue. We are not collecting any of the personal identifiable information and the PII, like MAC addresses or anything like that. We're simply saying how many devices are in the access points association table, and that comes back to us as a number.
Let's see, other questions that we have. What's the percentage of subway Wi-Fi users versus all passengers?
Oh, that's a really good question. Rail operators are constantly trying to understand that question of how many riders there are. So we have a really clear understanding of how many people are using the Wi-Fi, right? We have all kinds of various systems that track this. But to know the penetration rate, we would need to know how many people are riding the system. In Toronto, it's not a closed loop system, meaning that you might tap to get in, but you don't need to tap to get off. Or you might come in on a bus and the bus takes you into the subway space or location, so you don't go through a turnstile. So lining up the amount of people who have come from a bus versus the people who've walked through the door, it's really hard to tabulate all of that. And what various rail operators will go out and deploy manual people counters. So people holding, the same thing bouncers hold to keep track of how many people have come in and out of the club. they will count those people coming in. They typically do that, a handful of times a year. And then from those, that's how they establish those counts. The problem is, that fluctuates with the season, the weather, sporting events, all of that sort of stuff. So we can see everyday changes in those patterns where the counts are done at a much lower granularity, so they don't always line up. But to answer the question, somewhere between 10 and 20% is the penetration rate. I think a pretty rough number, where 15 is probably a good estimate.
I remember when you and I spoke about this use case, you reminded me that when the Warriors lost against Toronto, you guys saw very specific behavior with
we've actually,
Toronto fans.
First of all, Raptors, we did it. We did it. I mean, I think technically because we're now 2 years undefeated, right? I don't know if that holds up, but we actually released a white paper on the anniversary, which was, I believe, last Saturday, about all of the interesting things we saw as a result of the Raptors winning. So, that pattern I showed of people joining the Wi-Fi, the pattern of associations in the morning and then rush hour. Well, one of the things we saw that was really cool was when stations opened the following morning, the amount of associations were the highest they'd ever been, right? So, 5 a.m., we start to see people associating outside of the location. Then as soon as the doors open, they spike up. What we suspected happened were people spent the whole night partying right until they could get the subway home in the morning, right? And so that was really interesting to see, because that's not very typical behavior. So if you're interested, there is a white paper at BAICommunications.com where we go through all of this interesting, all the different insights we saw based on, the Raptors winning, the kind of data that was being used, how many Instagram posts, how much Instagram traffic we saw, things like that. So definitely check it out if you're interested. Yeah,
only if you are not a Golden State fan.
It was our year. What can I tell you?
So Iona asks, are you calculating a baseline to know what the normal crowding level is for each station?
Yeah, so when I referred to those parameters, right, we basically have a lookup table, a database with different variables that we tweak in the business logic, and that's exactly to achieve, what was asked. How do we tweak for the different base levels of the different stations? And that's something we're still refining and iterating over. Certainly with COVID-19, we've seen drastic changes in the way people are using transit. And so with this solution, we're able to change those knobs to go from overcrowding to when do we believe, people are able to observe social distancing at the platform level and things like that. So I don't think we've necessarily established a clear baseline, but rather we're constantly refining what we're seeing in order to come up with a way of teasing out those signals which indicate overcrowding. How was that? Score of 0 to 10 on answer.
Oh, that was great. So you're gathering, how many associations you have, what's the RF signal? How about bandwidth? How do you, because, in that first tweet that you showed, they were saying Wi-Fi sucks, and it could be a bandwidth issue, right? So how are you gathering metrics with bandwidth? What protocols are you using? And
yeah, so we have an incredible networking or team of networking engineers, and that team also manages the Wi-Fi infrastructure. We have a lot of policies in place to try and implement fair use, trying to ensure that everyone gets a good experience and not one person is monopolizing the entire bandwidth. So that some of that is built into the appliances we purchase. Some of that is a factor of the RF performance, so how we have the access points designed is to cover the entire station. But there's a few factors that are involved there. It's not typically a bandwidth issue when you have these network sizes. It's about infill or amount of devices that are trying to associate to the access points. So it's a balancing act between adding more and more access points to provide access for people versus the RF management. So a good analogy might be if you have a room, the more people you add to the room, the more conversations you can have, but the noise level starts to go up and people start to get louder. And at a certain point, it gets so loud that people have a hard time hearing each other. And this is really the same sort of phenomenon that happens in small congested RF space. Devices are talking to access points. You want as many as possible, but you want to make sure it's not so many that the signal to noise ratio really makes it hard for that communication to happen.
Okay. So Richard asked a follow-on question to that. So have you done anything around capacity management with the bandwidth? For example, backhaul capacity from
all
of
these follow-up questions. So I won't go too far into it because that's more of a question for the Wi-Fi engineering team. I think there's a fair amount of white papers that are provided. I will say that we have 72 kilometers of fiber, all diverse path. We have the multiple different data centers, and we have multiple different gigabit links to provide that connectivity to users.
I think the tricky part, Jeremy, is that you're in a business that every one of us on this call has direct experience with, right?
Yeah.
All of us have dealt with Wi-Fi in some form of public transportation, and we all have we're very opinionated on how well those networks are performing and how we could do it better.
Yeah, I completely understand. And a lot of times this comes down not to the technology, but to the business use case, right? So how would a place like a coffee shop offer the sort of Wi-Fi experience people like you and I are trying to get, where we're trying to VPN while we're working with some remote database while streaming Netflix? How do you deliver that to the 50 people in the coffee shop you might have? Well, you might not be willing to invest all of the money to deliver that to all of the users. So what's really nice about BAI Communications approach is that we're looking to have multiple revenue streams based off that Wi-Fi infrastructure, which allow us to invest more to deliver that capacity because there's more ways we can monetize it. So the digital signage, for example, the digital signage, has nothing to do with the public-facing Wi-Fi. It's using the same infrastructure, so we're allowed to do it very cost-effectively, and as a result, that brings in more revenue, which justifies, more investment in that infrastructure. So that's really what it's about. Is how do we, or that's how we're able to scale these solutions, which provide very good user experiences at that kind of scale of an entire subway network. Right?
Yeah. So Jamie comments, good presentation, invites good questions. So proves that we're all engaged. Richard followed up with, thanks, Jeremy. Solomon has a great comment. Data equals money. Let's see. Oh, Richard, thank you for reminding me. Let's go to the swag questions. What are your questions
swag.
For everybody?
What are my questions? Oh, I thought they would be, I wrote them down somewhere.
I have them. I just thought you might want to ask them. Oh boy. Let's see.
What are the 3 key verticals that BAI Communications plays in?
Yep, question number 1.
So that's related to who BAI is.
Mm-hmm.
Question number 2, what was the name of the user emulation project we built. So what was the project name? And that which led us to InfluxDB originally. And number 3, how does social media typically describe the Wi-Fi engineers at BAI? We
Very
will,
funny.
number 3 will accept a wide range of answers, right?
Oh, you're going to have to check the Slack channel. We're going to get some pretty interesting answers to some of these things.
I'm seeing attractive.
Boom. Get that person some socks.
So as we just wait for these answers, any closing thoughts to our audience today about your solution or about what you guys are doing, or
yeah,
are you guys hiring? We're always, wanting to promote too if there's open positions.
Yeah, I think we shared, this is one of the use cases. There's probably 15 to 20 different use cases, all based off Wi-Fi analytics specific in the rail industry. So hopefully as those mature, hopefully I'll get to share those with the community moving forward. And then what I'd say is I've really enjoyed working with Influx. I have a bit of a development background. And obviously we're doing some data analytics, and this is a really good tool. I described it as cornerstone in the past because you can write some scripts which essentially just push JSON to an endpoint, and then you can start building your APIs or your visualizations on top of that, and that really allows us to hit the ground running. So we operate as a small, almost like a research and development team for building out these POCs to different rail operators. So they'll come to us with a question. We'll say, well, let's have a look and see if we can solve that problem using data. And really, we rely on Influx to give us that agility to do it. So huge fan of Influx, and I'm excited to continue using the product as you guys bring in more features and take it to 2.0 and beyond.
So you want to give everybody the answers to the 3 questions?
Yes. So BAI Communications, neutral host, 5G, broadcast, transit and safety. For the name of the project, it was the Touchstone project. And then for acceptable answers for number 3, we'll take attractive, handsome, intelligent, punctual, cunning, clever, really any positive thing you want to say, we'll accept as an answer. You'll get some socks.
Awesome. All right. So the winners are Chris Jones. You actually got number 1 right. So we're definitely giving that the swag to you. Ernesto Barreto and Mr. Richard Pearson, who was asking a lot of those questions. Not only did you get that question right, but yeah, we appreciate your involvement in this presentation. Thank you so much. All right, cool. Well, Jeremy's going to be hanging out in the InfluxData speaker chat. So if you have any more questions, or if you want to give him a hard time about any of those descriptions of the engineers, Wi-Fi engineers. I think Ernesto has the best one. Magnificent and gorgeous. I couldn't agree with you more. That is awesome.
That man gets a t-shirt.
Yeah, he already got one.
Perfect.
So Jeremy will be hanging out in the chat, and let's keep going. And we're going to switch over to Johnny. Let me see if Johnny is ready. Yes, Johnny is ready. And we're going to start, if it's okay with you, Johnny, just 2 minutes early. So we'll switch presentations. So Jeremy, thanks a lot. If you can.
Thank you so much.